Well, you're in for a treat today. And don't you deserve it? I think you do. You've been working hard. I think you've been working hard. And this is going to be a really short lesson. Um, just a quick look-see at the parent graphs of all parent graphs. We don't even have to talk about sine or cosine, but we do probably need to spend a little time talking about the reciprocal of sine theta, which is, of course, cosecant theta, and the reciprocal of cosine theta, which is, of course, secant theta, plus, shouldn't we talk about tangent theta and cotangent theta? We know that tangent, when we graph it, has asymptotes every place that, let me think about tangent a minute, tangent theta is y over x. So every place, if you think about the unit circle, every place that your x is equal to 0, which happens at 90 degrees and at 270, all those places you have asymptotes. And in between the asymptotes, what does it look like? This. Then we've got cotangent, which is the reciprocal partner. And here, if you think about a circle, it's going to have an asymptote every place that y is equal to 0. So at 0 degrees, 180, and so forth. And when you graph that, it graphs between the asymptotes, going from positive infinity down to negative infinity. So I think we kind of already covered it, but we'll spend a few more minutes looking at this. Using periodicity. Oh no. See, if I think about it, I can't say it. Anyway, using this, we can examine sine and its reciprocal partner, cosecant. We notice that the range for cosecant excludes everything except the peak and the valley point of its associated sine function. Same is true for secant as it relates to cosine. Notice that every place that sine is 0, it has an asymptote, as you would know, because where sine is 0, 1 over whoops, 1 over that function, it's going to be cosecant. Every place that that is 0, this will have an asymptote because we never let the denominator go to 0. Same true here. Every place that cosine is 0, that's where your asymptote is for secant. We already talked in our preliminary here about tangent and cotangent. You notice every place that tangent is 0, or that function is 0, its reciprocal has an asymptote. Every place where a cotangent is 0, its reciprocal partner, tangent, has an asymptote. So that's why you see them 90 degrees off. This is what you have in your book. Let's go through it. Asymptotes. Remember, when you draw any of these other trig graphs, you must put those asymptotes in. Tangent. What is its period? We know that period is defined as from the beginning of the cycle to when the cycle begins again, when it starts to repeat itself. So we're going here from 90 through 180 to 270. What's this length? Right, we've talked about this before. How else could we express that? And actually, I should have expressed it as in degrees, right? Because we were looking at degrees. So 180 degrees. Cotangent is also 180 degrees. One of the nice things is the period matches its reciprocal partner. We already know the period for sine, it's 360 degrees. It's, that's not a bad idea. Draw it in. When you have to do a graph of cosecant, draw its reciprocal partner. We're so familiar with the sinusoid. Then you can see every place where there is a 0, that's where you put in your asymptote. And between the asymptotes, you draw these U-shaped branches, 360 degrees. So a few tips here on how to graph. And on this one, if you want to do a secant graph, start with cosine. See how that graphs? Every place you have a 0, that's where you've got an asymptote. And just like cosecant, just like cosine, just like sine, 360 degrees. I told you it was a treat. Only 7 minutes of instruction. I hope this is a day when that will be useful to you. See you back in class. Well, let's call it 8 minutes.